Hello, my students in grade 9. This is a mathematics lecture in our lesson, which we started 3 weeks ago, lines and coordinate system. But today we are going to talk about analytical geometry. What do we mean by analytical geometry? Analytical geometry means we are going to apply geometrical rules in a coordinate system. In geometry, we have learned a lot of rules. So let me give you example. How is geometry going to be in coordinate system? We have learned in geometry Pythagoras theorem. So we will use in the coordinate system Pythagoras theorem to prove a right triangle. Also, we have learned how to write equations of lines in the coordinate system. We will write together the equation of a perpendicular bisector of a segment. We will write the equation of a height. Also, the height, we learned it in geometry. We will write the equation of a median segment. And finally, we will find the center and radius of a circle circumscribed about a right triangle. Let us start with examples. Given the points A, which has coordinates 6, 2, B, -6, 6, and C, -2, -2. First, I will ask you to calculate the length of AB, AC, and BC. In our lesson coordinate system, we learned how to calculate the length of segment. For example, segment AB equal big radical XA minus XB all of its square plus YA minus YB all of its square. This is a rule. So we replace XA, XB, YA, and YB. And after calculation, I want to tell you something. Whenever you have two signs after each others, we should make them one. So negative times negative is positive. And after calculation, we get the answer of the length of AB is 4 radical 10. Also, using the same rule, we calculate the length of AC and the length of BC. After calculating the three lengths, now I will ask you, deduce the nature of a triangle ABC. What kind of triangles is ABC? Is it right? Is it isosceles? Is it equilateral? If I look at the three answers, the length of AB, the length of AC, the length of BC here, we can see that we have two equal sides. Who are the equal sides? Side AC is equal to side BC. Side AC is equal to 4 radical 2, and side AC is equal to 4 radical 5, and side BC is equal to 4 radical 5. So directly I say, any triangle having two equal sides, I will say, since triangle side AC equals side BC equal 4 radical 5, then triangle ABC is isosceles of vertex C. But I'm not done yet. I should make sure that my triangle is also right. To prove that the triangle is right, I have the length of AB, so I get AB square. So AB square is equal 160. I have AC, so I can calculate AC square, which is 80. Also, I have BC 4 radical 5, so I calculate BC square, which is also 80. If I added the two small sides, AC square plus BC square, so 80 plus 80, which is equal to 160, which is equal to the AB square. So as we learned in geometry, using the converse of Pythagoras theorem, then triangle ABC is not only isosceles, it is right isosceles at C. So this is the first one. Now, we move on. Now we will see how can we find the center and the radius of a circle circumscribed about a triangle. Also in geometry, we learned that in a right triangle, always there is a circle passing through the three vertices. It is circumscribed about the triangle. And in any right triangle, there is a hypotenuse. So suppose I have triangle ABC right at A, then my hypotenuse is BC. Okay, since it is a right triangle, then the center of the circle circumscribed about the triangle is the midpoint of the hypotenuse BC. So, in a coordinate system, if I have again the coordinates of A, the coordinates of B, the coordinates of C, we have learned how to calculate the coordinates of a midpoint of a segment. So we say, let I be the midpoint of segment BC, which is I, which is the center of the circle. So since I is the midpoint of segment BC, then I can write XB plus XI equal XB plus XC over 2. Okay, I use the coordinates and XI is equal to -4. Also, YI equal YB plus YC over 2, then YI is equal to 2. Then the coordinates of I are -4, 2, and I is the midpoint of the circle. I is the center of the circle circumscribed about the triangle ABC, and it's the midpoint of the hypotenuse BC. Now, if I is the midpoint of the hypotenuse BC, then who are the radii of this circle? IB is a radius, IC is a radius, and IA is a radius. So, how can I calculate the length of the radius? IB equal IC equal BC over 2. So I can get the length of BC using the length rule, which is XB minus XC all of its square plus YB minus YC all of its square. If I divide this length by 2, then I get the radius of the circle. So this is how we find the coordinates of the center of the circle circumscribed about a right triangle, because this is only applied to right triangles, and this is how we calculate the radius of the circle. And also in geometry here, as we learned before, if we have a circle of diameter AC and center O, B is a point on the circle, then angle ABC is an inscribed angle facing diameter, then this angle will be right angle. It is an angle facing diameter AC. The same concept we are applying here, but in an opposite way. Let us continue. Now, how can we write the equation of the perpendicular bisector of a segment? Given the points B and C with their coordinates, and also we are given the equation of line BC, which is y equal minus half x minus 3 over 2. What should we do in this question? The question here is, we should write the equation of line L. What is line L? It is the perpendicular bisector of segment BC. Let us stop here. I taught you before in the lectures I sent, to write any equation of line in a coordinate system, we need two things. We need the slope of this line, and we need a point belonging to this line. Let us go to geometry information that we learned before. We know that the perpendicular bisector of a segment is a line perpendicular to the segment at its midpoint. So this line L will pass through the midpoint of segment BC. So we should have the coordinates of this point. So let M be the midpoint of segment BC, and we calculated the coordinates of the midpoint. Now, this line L is perpendicular to BC. Then we say, since L is perpendicular to BC, we learned a rule in coordinate system, how we find the slope of L using perpendicular lines. We have a rule that says the slope of L times the slope of BC equal -1. From the equation of BC, we can get the slope of BC, which is -1/2. The slope is what we have in front of X. So this is the slope, it is -1/2. So now I say the slope of L times I replace the slope of BC by -1/2 is equal to -1. Then the slope of L is equal to -1 over -1/2. This is a compound fraction. Then the slope of L is equal to 2. Now, after I got the slope of L and I got the coordinates of the point belonging to line L, I say M belongs to line L, since line L passes through M, then Y minus YM equals slope into X minus XM. I replace YM by -1, I replace the slope of L by 2, and I replace XM by -1. Then after calculation, -1 times -1 is +1, -1 by -1 is +1. So I get the equation of L, which is Y equal to X plus 1. Now, we are given 3 points, A, B, and C. A, which has 2, 0, B, 3, 5, C, -1, 1. What we are going to do here is we should find the equation of line BC first. To write the equation of line BC, this is the equation of a line passing through 2 given points B and C. So we should also find the slope of BC and a point belonging to BC. We have a rule for the slope of a line passing through 2 points. We have learned this rule. So the slope of BC equal YC minus YB over XC minus XB. After calculation, I got the slope of BC is 1. Now, line BC passes in 2 points, which are B and C. So we can take any of these 2 points belonging to the line. I took B. Point B belongs to line BC, so Y minus YB equals slope into X minus XB. I replace YB by 5, the slope is 1 and XB is 3, and after calculation I get Y equal X plus 2. This is the equation of line BC. Now he is asking me to write the equation of H. Let H be the foot of height drawn from A in triangle ABC, and we should write the equation of AH, which is the height in triangle ABC. Here I should go back to my geometry question, to the geometry information I have in my mind. So since AH is a height in triangle ABC, then I say a height is a line from the vertex perpendicular to the opposite side. If I am drawing the height from vertex A, so it's going to the side, opposite side, which is BC, then AH is perpendicular to BC. So from the equation of BC, I can get the slope of BC, which is 1. The slope is the number before X. So slope of AH times the slope of BC is equal to -1. I replace the slope of BC by 1, then the slope of AH is equal to -1. Now, A belongs to line AH. Then Y minus YA equals slope into X minus XA. I replace and calculate, then Y equal minus X plus 2 is the equation of line AH. Also, we are given these 3 points. We should write the equation of AM, the median of BC. Also, if I revise my information, what's a median? A median is a line from the vertex to the midpoint of the opposite side. So I should have the coordinates of M, which is the midpoint of side BC. Then I say M is the midpoint of segment BC. So XM is equal to XB plus XC على 2. This is the rule of calculating the coordinates of a midpoint, and YM equal YB plus YC over 2. So M has coordinates 1 and 3. Now, Line AM is passing through 2 points A and M, and both points we have their coordinates. So the slope of AM, also using the rule of slope, we got slope of AM equal 1. Now, A belongs to line AM or M belongs to line AM, so Y minus YA equals slope into X minus XA, and we get the equation of AM, which is Y equal X minus 2. I want you please to watch this video well and to apply every exercise I applied with you. If you didn't practice, you will be doing nothing. Watch the video well, and if you have any question, please contact me. Thank you.